Good morning, students. I'm a faculty from Chemical Engineering Department. My name is Dr. G. Kirtika. I am handling Engineering Thermodynamics. In today's class, we'll see some of the assignment problems which was discussed in Unit 1. So, coming to assignment 1, we are now currently discussing the problem number 3 from Unit 1. Okay, the assignment sheet is already been shared with the students. Let me read out the problem for you. So, illustration of first law of thermodynamics. So, question number 3 is for illustrating first law of thermodynamics. Calculate del U and del H for 1 kg of water when it is vaporized at constant pressure and temperature of 101.3 kilopascal and 100 degrees Celsius. So, what we need to find here is del H and delta U. What is given in the question is constant pressure. So, constant pressure is given in the question. Pressure of 101.33 kilopascal is given. For this, change in heat in the amount of 2256.9 kilojoules is added to the water. So, during the process of vaporizing, a heat of Q of this amount is being added. The specific volume of liquid, specific volume is represented by small v, and since it is for liquid it is L, and since for vapor it is mentioned as V. The specific volume of liquid is this much. In meter cube is a volume per unit kg, so it is meter cube per kg. Similarly, the specific volume of vapor is also mentioned in the question. So as I have written down, we need to find out delta H in this problem and also delta U. Okay, so now we know that. What is that we know from the first law of thermodynamics? So from first law we know that delta H is equal to Q, that is equal to Cp delta T for a constant pressure process. So when you have a constant pressure, as mentioned in this question, when you have constant pressure, delta H is equal to Q. So whatever Q was given in the question, the data which is mentioned in the question is nothing but delta H. So that is the first interpretation in this problem. So delta H at constant pressure is equal to Q. Okay, next, what else we need to find? We need to find delta U. In the question, we need to find delta U. For delta U, we know that from the first law of thermodynamics, delta H is equal to delta U plus delta PV. For first law, we know that H is equal to U plus PV. So, enthalpy is equal to change in internal energy plus delta PV. So, let us analyze and find out delta U. So, next step is to find delta U. In the problem, we need to find delta U, change in internal energy. We know that H is equal to U plus PV. So, we can rearrange this equation and write it as in terms of U. So, delta U equal to delta H minus P delta V. So, here you can specifically see I have taken pressure outside because it is a constant pressure system. So, pressure was taken outside and only changes with respect to its specific volume delta V. So, this is our formula. So, change in internal energy is equal to change in enthalpy minus P into change in specific volume. Again, so let us find out this term. So, let us find out the second term for finding delta U. P into delta V. So, pressure is given in the question. In the question, you can find out that the pressure was 101.325 kilopascal into change in specific volume. So, the water is vaporized from liquid is getting vaporized to vapor. Okay. So, there is a change from liquid to vapor. So, we have to find the difference in the specific volume of vapor, which is final state, minus liquid, which is initial state. So, change in vapor volume minus change in liquid volume. Let us substitute the values for specific volume, which is 1.673 meter cube per kg. So, here the units are meter cube for 1 kg of the water. Minus point, again the value which is given, which is for specific volume of liquid. So, let us assume that for the mass of the system as 1 kg. Okay, when you assume the mass as 1 kg, you will have a unit of meter cube alone. Let us come and see the units of pressure. Okay, units of pressure is important here. Because in the question it is mentioned as kilopascal. So what is Pascal? Pascal is nothing but Newton per meter squared. Okay, Pascal is alternatively written as Newton per meter squared, which is 1 Newton is equal to Joule per meter. Again, I am substituting for Newton, which is Joule per meter. So you will get Joule per meter cube in this pressure unit. Okay. So again, so you can see here the units I have noted down over here for pressure and volume, which is kilojoules, because it is kilopascals. So kilo has come here, kilojoules per meter cube into volume unit, which is meter cube. So your meter cube and meter cube will get cancelled. You will get the final unit as in kilojoules. So this unit conversion and understanding is very important in this problem. Again, you can directly substitute, you can multiply this 101 and subtract these two values. You will get the final answer as 169.4, which is kilojoules. So here this term is in kilojoule. Delta U we need to find, and delta H was calculated in the previous step. So from the previous step I have substituted the delta H values, which is in kilojoules, and P delta V values, which is also in kilojoules. So if you subtract these two values, you will get the final answer for delta change in internal energy, which is 2087.5 kilojoule. So this summarizes the problem where we have found delta H. We have found delta H to be delta H to be 2256.9 kilojoule and delta U to be 2087.5 kilojoules. Thank you. So the next problem is question number 7. Assignment sheet, unit 1, question number 7. Let us read out the problem. The liquid water at 453.5 Kelvin, 180 degrees Celsius and 1002.7 kilopascal has an internal energy of 762 kilojoules per kg. So you can write down the given details from the problem. Internal energy U1 is mentioned as 762.0 kilojoules per kg. Specific volume means small v. Okay, I would have written here. So specific volume, so V1 is 1.128 centimeter cube per gram. What is its enthalpy? So what is its enthalpy is the first part of the problem. So let us solve the first part. We know that delta H is equal to delta U plus delta PV. Okay, as per first law, the enthalpy can be related to internal energy using this equation delta H is equal to delta U plus delta PV. So in the question is internal energy given, pressure given and specific volume is also given in the question. So let us take those values. So H1, because we are going to move towards the second process, I have noted down as H1, enthalpy 1 plus is equal to internal energy at the first condition, pressure into specific volume 1. So internal energy is given in the question, which is 762 kilojoules per kg, plus pressure is given in the question, which is 1002.7 kilopascal. As done in the previous problem, we need to convert kilopascal to joules per meter cube. So we know that kilopascal is equal to Pascal is nothing but Newton per meter squared. So Pascal is Newton per meter squared, and Newton per meter is nothing, Newton is nothing but joules per meter. So you will get kilojoules per meter cube with the same units. So this, instead of kilopascal, I can write the units as kilojoules per meter cube. Volume, specific volume. Please go and see the question. It is 1.128 centimeter cube per gram. So we are in a position to convert this centimeter cube per gram to in terms of SI units, which is meter cube per kg. So specific volume V1 is 1.128 centimeter cube per gram. How do we convert this centimeter to meter cube? So into 10 power minus 6, it will give you in meter cube, and you also need to convert grams to kgs. Okay, so put the appropriate conversion. So ultimately you will have 10 to the power of minus 3 meter cube per kg. So this conversion need to be added to the specific volume to solve the problem. So H1, how did I get H1? That's what. So H1 is 762 U1 plus pressure plus specific volume into the conversion which we seen. So if you multiply the P and V and add it with U1, you will get the final answer of 763.13 kilojoules per kg of H1, enthalpy at point 1. So let us go to the second portion of the problem. The water is brought to the vapor state at 573.15 Kelvin, 300 degrees Celsius and 1500 kilopascal, where it has an internal energy of 2784.4 kilojoules per kg. So in the second part, again internal energy is given, okay, internal energy is given, and the specific volume is 169.7 centimeter cube per gram. So specific volume for the second condition is also given. Calculate delta H and delta U for the process. So delta U, what is delta U? Change in internal energy. So U2, internal energy 2784 is given in the question, minus U1, which was already given in the first part of the question. So by subtracting the two internal energy, you will get the change in internal energy as 2022.4 kilojoules per kg. Okay, you have found delta U by this method. Let us move to delta H. What is delta H? Similarly, change in enthalpy of the second process minus change in enthalpy of the first process. First process, do you know from the previous step? Yes, it has already been calculated from the previous step of this first part of the problem. Do you know H2? H2 is not known, but we need to find the same H2 by the previous method. So H2 is U2 plus P2 into V2. Is U2 given in the question? Yes, it is given, right? 2784.4 kilojoules per kg it is given. P2, pressure, is pressure for the second step mentioned in the question? Yes, it has been mentioned as 1500 kilopascals. So 1500, as I said, the pascal corresponds to some other units. So I have written it as kilojoules per meter cube. Into volume, specific volume, right? So specific volume was in centimeter cube per gram of 169.7. I have multiplied with 10 to the power of minus 3 so that it changes to SI units of meter cube per kg. So U2 is given in the question, P2 is given in the question, second part of the question, and V2 specific volume was also given, which is converted to meter cube per kg. So add, multiply and add these values, you will get final H2. So final H2 of the process is 3038.95 kilojoules per kg. So what is asked in the question? It's not enthalpy, it is change in enthalpy. So we need to subtract H2 minus H1. So H2 values are known, H1 values is also known. Subtract the two H2 and find the difference in enthalpy as a final answer. Thank you. Question number 9 from assignment sheet. So assignment sheet, unit 1, question number 9. So let us read the question. A tank containing 20 kg of water at 293.15 Kelvin. So we have a tank which has water filled in it. The water is at a temperature of 20 degrees Celsius initially. Water is at a temperature of 20 degrees Celsius. Mass of 20 kgs. So M is mentioned as 20 kgs. Is fitted with a stirrer. A stirrer that delivers work to the water at the rate of 0.25 kilowatt. So the work done by the stirrer is mentioned. Okay, so let us see that W is mentioned, 0.25 kilowatt. And the temperature of the water is also mentioned. How long does it take for the temperature of the water to rise to 30 degrees Celsius if no heat loss from the water? So assume that from the first law, if there is no heat loss, Q should be equal to W. From Joule's experiment, we know that if there is no change in internal energy, then Q, the heat evolved or heat supplied, should be equal to the work done by the system. So assuming Q equal to W from the given statement, we need to solve the problem. How long does it take? It means they are asking the time required to reach 30 degrees Celsius. For Cp of 4.18 kilojoules per kg degree Celsius. So Cp is given in the question. 4.18 specific capacity of water at constant pressure is 4.18 kilojoules per kg degree Celsius. Okay, so what is that you need to find is the time. So do we need any formula for Q? Yes. So how do we calculate the the heat evolved for the change in temperature? So we know that Q is equal to Cp into delta T. For m kg of water, it is Q is equal to m Cp into delta T. Delta T is the rise in temperature of water due to the work done by the stirrer of 0.25 kilovolts. So M is 20 kg given in the question. Cp is also supplied in the question. Delta T. Delta T you can put in degree Celsius because the units has to get cancelled. So substitute in degree Celsius, which is 20 degrees is increased to 30 degrees. So the delta T will be 10 degree Celsius. So multiply and you will find the answer as 836 kilojoules of heat evolved. So we have to equate to the work done. So work done is given in the question. Work done by the stirrer is 0.25 kilowatts. So 1 watt is equal to 1 joules per second. Okay, 1 watts is equal to 1 joules per second. So that is equal to, I have converted that into joules per second, multiplying it by kilos. So 0.25 corresponds to 250 and watts corresponds to joules per second. So now let us balance the units. Q, we are about to equate Q and W. So Q unit is in kilojoule and W unit is in joules per second. So time taken to reach 30 degrees Celsius. We need that how long, the duration of the time required to reach 30 degrees from 20 degrees Celsius. So we can multiply this for unit consistency also. You can think and multiply 250 into time required to reach a heat of 836 kilojoules. So we are substituting in joules on both sides. So I have this conversion of 10 to the power of 3. So again you can see here this is joules per second, which is watts. Time units will be in second if you find out, and here you have Q units as joules. So we are equating Q is equal to W and finding the time required to reach a particular temperature of 30 degrees Celsius, which will have final answer as 0.92 hours. So second you need to convert that into hours. So thank you. The next question is problem number 11 from assignment sheet 1. This illustrates first law of thermodynamics for open system. So let me read the question. A hydro turbine operates with a head of 50 meter of water. Okay, so the head developed by the turbine is 50 meters of water level. Inlet and outlet conducts are in 2 meter in diameter. So inlet both in tube, it is a common tube where inlet dia and outlet dia is same with a diameter of 2 meters. That is also given in the question, so that you can find the area of the tube. Estimate the mechanical power developed by the turbine for an outlet velocity of 5 meters per second. So they have given the velocity at the outlet. So U2 or U is 5 meters per second. You need to find out the mechanical power developed, which is W. So this is an example for a flow system, first law for flow system, where we know that the formula is Q plus W is equal to change in kinetic energy plus change in potential energy plus change in enthalpy. So here as we read the question, we can know that there is no change in kinetic energy. Kinetic energy is not changing from point 1 to point 2. So you can neglect the kinetic energy, but there is a head developed by the problem. Means the water is pumped to a height of about 50 meters. Okay, so you have to account for the potential energy. And enthalpy, so there is no discussion on the enthalpy, so you can neglect. So neglecting the kinetic energy and neglecting the enthalpy, and there is no heat evolved also. We need to find the work developed by the turbine for change in potential energy. So our first law for flow system is reduced to W dot is equal to change in potential energy. So what is the formula for potential energy? Potential energy is M dot G into delta Z. Okay, mg into H, where H is nothing but the head developed, which is delta Z. Do we know M dot? M dot is mass flow rate. It has a unit of kg per second. As previously discussed in continuity equation, you know that M dot can be calculated by using the formula of velocity into area into density. So you can substitute the appropriate units and find out that the units of M dot is kilojoules per second. So M dot U. Do you know the outlet velocity? Yes. So 5 meters per second is given in the question. Area, the area of the pipe remains to be the same with a diameter of 2 meters. So you can find the area using the formula pi by 4 d squared. So area is also known in the M dot. Density. What is density of water? Density of water, you can assume it as 1000 kg per meter cube. Okay. So you can find M dot from this, where all the other given details are known. M dot equal to 15,700 kg per second is the answer. Again, what we need to find? W dot. So W dot is equal to, yeah, W dot mgh, right? Yeah, W dot equal to change in potential energy, that is equal to m dot g into delta Z. M dot is known, 15,700. G is gravitational constant, which is 9.8 meters per second squared, and delta Z is 50 meters. So if you multiply the three terms, you will find W dot. The formula, the answer for W dot is 7693 kilowatts. Thank you.